Today, we are diving deep into the world of ethical hacking, and it's a field that's built on this really fascinating idea. To build a truly unbreakable fortress, you first have to learn exactly how to tear it down. We're going to walk through the exact process security pros use to find and fix those weak spots before the bad guys even get a chance. So this is the big question, right? It's what keeps security folks up at night. You can build all the digital walls you want, you can set up all the fancy alarms, but are they actually going to stop a determined attacker? And really, the one thing you can't afford is to wait for a real attack to find out the answer. Well, the answer comes in two parts. First, you need a perfect blueprint of your own fortress. You have to understand the network itself, inside and out. Then, you need a standardized playbook for the attack. And for that, the pros rely on the NIST framework, which is basically a step-by-step guide for testing defenses. So let's get into it. So our journey today is going to follow the 6 main stages of a professional penetration test. We'll start with the blueprint, figuring out what a network even is. Then we'll set the rules for the hunt. After that, we'll draw our map, launch the attack, see what the damage is, and finish up with the final report. Let's get started. First things first, you just can't test a fortress without knowing its floor plan. And in the world of cybersecurity, that means you have to understand the fundamental architecture of a network. You know, how all the digital rooms and hallways connect and talk to each other. So networks, they operate on different scales. At the smallest level, you've got a personal area network, or PAN. Just think of your phone connecting to your headphones. Then you have a local area network, a LAN, which covers a single building, like your office. And finally, the wide area network, the WAN, connects everything else. Cities, countries, you name it. The internet itself is the ultimate WAN. Okay, so how do all these devices actually communicate? Well, they follow these really strict rule books, or models. The 7-layer OSI model is the theoretical one. It's kind of like a diagnostic chart that helps you figure out where a problem is. But the 4-layer TCP/IP model, that's the one that actually runs the internet. For a pen tester, knowing this model is like a firefighter knowing the exact layout of a building before they run inside. All right, so we understand the territory. Now it's time to plan the hunt. But listen, this isn't the Wild West. Ethical hacking operates under a super strict code of conduct. And these rules, they're what separate a security professional from just another criminal. This document right here is maybe the most critical piece of the whole puzzle. It's called the Rules of Engagement, or ROE, and it's the legal contract that makes the whole test legit. It draws a very clear line in the sand, defining what's allowed and what's totally off limits. This is what keeps the test from accidentally breaking the business. Let me put it this way. Without a signed ROE, you are not a security tester. You are a criminal. It's that simple. A really solid ROE covers all the bases. It spells out exactly which systems are fair game and which ones you can't touch. It sets the testing window, usually after hours, so you don't mess things up. It also forbids dangerous moves, like attacks that could take the whole system down. It sets up an emergency contact plan, and most importantly, it has that signed authorization from the higher-ups. Okay, the rules are in place. The test begins. The first active phase is all about reconnaissance, or as I like to call it, casing the joint. Just like a detective, the tester starts by meticulously mapping out the target's entire digital footprint. You know, this whole process isn't just made up on the fly. It's all laid out in frameworks like this one from NIST. So right after the initial planning, the first major step is information gathering. And this is pure intelligence work. The goal here is to build a complete list of every single server, every device, every potential way in that the organization has exposed to the world. During this phase, testers are basically hunting for digital addresses. And there are 2 main types you need to know. The IP address is like a building's street address. It tells you where to find a device online, and it can totally change. The MAC address, though, that's more like a device's unique serial number, literally burned into its hardware. Finding both gives a tester a much clearer picture of what they're up against. So what are they actually looking for? Honestly, everything. The network's layout, its topology, any open digital doors, which are called ports, and what services are running on them, like FTP on port 21. They try to figure out the operating systems. They map out all the IP addresses and subnets, and they even try to find publicly available user accounts. And a slide like this really drives home just how much knowledge is required to do this stuff. You see, a good tester isn't just someone who knows how to run a tool. They have to be a master of network fundamentals. They have to deeply understand everything from network layouts to the little details of the TCP/IP model. All right, the map is drawn. Potential weaknesses have little red circles around them. Now comes the moment of truth, the attack phase. This is where a tester goes from just finding a potential weakness to actively exploiting it to prove it's a real-world threat. And this brings up a really common question. You see, a lot of organizations run these automated vulnerability scans. They get a nice report with a list of issues and they think, great, we're done. But is that really enough to be secure? This table really shows the huge difference. Automated tools, they're like a security guard checking 1,000 doors to see if any are unlocked. They're fast, they cover a lot of ground. But a human tester, they're like a detective. They don't just check for unlocked doors. They're looking for a loose window frame, a weak spot in the wall, or a clever way to just talk their way past the guard. They find those creative, contextual flaws that a machine would just never, ever see. So here's the bottom line. Automation is definitely part of the puzzle, but it is not the whole picture. True security testing absolutely requires the creativity, the adaptability, and the contextual understanding that only a human expert can bring to the table. But you know, just getting in is only half the battle. The next phase, post-exploitation, is where a tester shows the true business impact of a breach. This is where they demonstrate exactly what a real attacker could do once they're inside the network. So after getting that first foothold, an attacker and our tester doesn't just stop. First, they try to escalate their privileges to go from being a regular user to an all-powerful administrator. Then they move laterally, using that first compromised machine as a launchpad to jump to other, more valuable targets. And finally, they prove they can steal the crown jewels by simulating the theft of sensitive data. Okay, the test is complete, the locks have been picked, the impact has been assessed, but the job is not done. The final, and you could argue most important phase, is the reporting. Remember, the goal isn't just to break in, it's to provide a clear, actionable roadmap for how to get better. A great penetration test report is really two reports in one. You have the executive summary, which speaks to leadership in the language they understand, business risk, and financial impact. Then you have the technical findings, which gives the engineering team everything they need, a detailed, step-by-step guide to reproduce the vulnerability, and more importantly, how to fix it for good. And that brings us to our final thought. A penetration test gives you this critical snapshot in time. It shows you where you're vulnerable right now. But in a digital world that is constantly changing, the real takeaway is that security isn't some project you just finish. It's a continuous process of building, testing, and rebuilding your defenses. The hunt for weaknesses, it never truly ends.